This is Valerio from the R3 product management team. I'm here with Dimos from platform engineering, who is going to demonstrate one of the main features of Corda Enterprise 4.2, storing confidential identity keys in HSMs. Dimos, can you tell us a bit more about what exactly you will be demonstrating and what's your environment for today?
Yes, sure. So we will be using a virtual machine that I have provisioned in Azure Cloud. I have deployed there two Corda nodes. We will see later on how we will register them with a network and execute some transactions with each other. The first node is configured with Primus X HSM to store the master key for confidential identity keys, and the second node will be using the local key store. So we'll be able to use both options we described in the previous presentation.
Sounds fantastic. And yes, as Dimos says, this comes off the back of the previous video we did to introduce this feature. We linked the video in the description of this one, so if you've missed that, please go and check that out. Okay, let's get on with the demonstration.
Let's get started then. So before we move on the demonstration part, I would like to give a very quick description of how the feature can actually be used. In the previous video, we already described how we need to configure our node, but I would also like to say some words about how the feature can be used from a programmatic point of view. So Corda provides this API called Key Management Service that provides two basic APIs. The one is a method called FreshKey that generates a key pair and returns the public key, and the second method is called sign, which receives the public key and a payload to sign, and internally retrieves the appropriate private key and signs the payload. So this component will behave differently depending on how you have configured your node. It can either use a regular private key or it can use a wrapped private key. Of course, on top of that, there are also other basic cordups built as part of the Flow framework. There is already a cordup called confidential identities cordup that provides some basic building blocks for generating confidential identity keys and exchanging them between nodes. And there is also other even more higher level cordups that make use of this cordup. So in this demo, we will use the finance cordup, which allows a node to execute cash transactions between other nodes using confidential identity keys.
Fantastic.
So let's get on with the demo then. Before we start, let's have a look at our configuration. So here we have two terminal sessions on the virtual machine we have provisioned in Azure. And we will see we have a directory with two nodes, party A and party B. So in the first session, we will visit the party A directory, and in the second session, we will visit the party B directory. And we can see briefly what are the contents of the directory. So we have a certificates directory that contains the key store for the network trust root. We have the Corda artifact for Corda Enterprise 4.2. We have a cordups folder with the finance cordup, which has two main components: the contracts part and the workflows part. The drivers folder needs to contain the driver library for the Primus X HSM. Then we have the node configuration file, and we have a couple more files that contain the credentials to authenticate with the Primus X HSM. Let's also have a quick look in the node configuration file. Most of the things you are already familiar probably, so we'll go through only some parts. We'll see that for most of the settings we have exposed public IP addresses. For example, we have exposed the database port publicly. The reason for that is that so that we can connect in the end of the demo and inspect a little bit the data that were generated. That's not necessary. And you can also see that we have we're using a public IP for the P2P address. One thing that is important to note is that if you want to reproduce exactly the same scenario using an Azure virtual machine, you will probably need to open the network access to these ports, because by default everything is locked down, so that nodes can interact with each other. We also see that we have explicitly opened SSH port for a cell connection, so that we can execute some flows later on. We have this line is used to explicitly whitelist the Corda, the finance Corda, because currently it is signed with a development key and is not trusted by default by the node. We also have a block that defines the network to which we will connect. We will be using a test network called DevNet for this demo, that you can also use for experimentation purposes. And the last part of the configuration is the fresh identities configuration block, which contains all the information necessary for the new feature. As we see here, the first node is configured with the wrap mode. It is using a Primus X HSM, and it will store the key under the alias master key demo.
And a reminder that wrapped mode is the most complete one.
Yes, this is the recommended mode. It's the fully secure one. And we see we also reference a Primus X configuration file here that contains authentication information for the HSM. Mm-hmm. We can show what is the structure of this file. It essentially contains the host and the port of the HSM device, mm-hmm. and it also contains the username and the password that are used to authenticate with the device and log into a specific partition in the HSM. If we look at the second node in the node configuration, it's exactly the same configuration. The only difference is the last block, where we will see we have a degraded wrap mode. We are using a local key store, and the alias is the same.
Makes sense.
So after that, I think we can proceed with doing an initial registration of the node using the initial registration command. The password for the DevNet network is password, as we can see here. As we said, it's not for production use, only for experimentation, so that makes it as easy as possible for people to use. So we'll copy that command, and we'll use it in the second node as well. We'll see here that a normal registration is performed, the necessary certificates are generated, etc., etc. And in the end of the normal registration, in this case, the node will also generate the master AES key that is used for wrapping the confidential identity keys. So we'll wait a bit for the registration to finish. And after that, we will try to inspect the local key store and the HSM to make sure that the key is generated there. Java comes with a tool called key tool, mm-hmm. that essentially allows us to do this introspection. So let's start from the first node that is configured with the Primus X HSM. We'll need to provide some additional data, like the driver that needs to be used, and the associated class in the driver. We use the list command to list the whole key store in a verbose mode. We also need to provide the credentials for the HSM and the type of the key store. You don't need to provide a password at this stage, and you will see that we have created a secret key under the alias master key demo.
Great.
Let's also do this quickly for the local key store. The command is going to be a bit simpler. We just need to provide the path to the local key store, which, as we already presented, is will be called by default wrapping key store PKCS12. So this will ask us for a password, and by default the same password is used for all the key stores. It can be adjusted, and it is Corda CA dev pass. So by giving the password, we also see that there is a secret key entry, and it's under the alias master key demo. So at this stage, we know that everything is in place to proceed. Let's clear our screen. And let's proceed to the second stage, which is starting the nodes. So we will start the nodes, and after that, we will connect to the first node with an SSH connection, and we will perform some transactions between the nodes. So let's wait a bit for the nodes to start up. Until that's done, we can create a new session for the SSH connection. I'll minimize the second window which corresponds to the second node, since we don't need to interact with it, and it's a bit more clear what we're doing. We're waiting for the first node to start up. We'll prepare the command to connect to it. So we'll do an SSH to port 2222, which is set up in the node configuration as we showed previously. We'll use the operator user, and we'll also need to specify the IP of the node, which we can pick up just from the console output. The password is also included in the configuration file. You can find it there. And we have connected to the first node. The first thing we will do is check what are the notaries that have been registered with this network with an RPC call, notary identities. And we'll see there are 4 notaries in this network, and we will use the West Europe for our demonstration. So first of all, we will create a cash issuance from party A to itself, and we will issue $1,000. So this will essentially create a new cash state, and this state will belong to the legal identity of party A at this stage. Now what we will do is we will do a cash payment from party A to party B. We'll transfer $100. The recipient, as we said, is party B. We need to specify that the cash transaction will use anonymous identities.
It is the important bit that allows us to use the feature, basically.
Yes, exactly. And we'll also specify the same notary. Hold on a moment. Probably missing some part in our command. Okay, let's try one more time. and we see the transaction going through now. What is happening now is both nodes generate two confidential identities on their side and exchange the confidential identities with each other. The first node is making a cash payment that transfers some cash, specifically $100 to the second node to each confidential identity. And the second node, and any change from that transaction will be returned back to the first node's confidential identity. So at this point, the transactions between the nodes are complete. What we can do now is we can also connect to the database of the first node to inspect the data in the new table. For this, we will use the H2 console, which is a tool you can use to connect to H2 databases, since H2 is the database we are using for our example. You can use the connection URL from the console output. The only thing you need to take care of is you need to replace the public IP with the right value. And the password is also contained in the node configuration file. So after connecting, you will see all the node tables here. There is a table called node R-key pairs. And if we look all the data included there, we will see that there are two entries with public key hash column. The private key, which importantly now is empty, is not populated, since we don't store anymore the private key in plain text. We also have the public key, and we have a new column, the private key material wrap, which contains the private key in an encrypted form. And lastly, there is a last column called scheme code name, which, as we can see, contains some information around ciphers and algorithms that are used by the generated keys.
Fantastic. And just to remind our listeners, this is still compatible with the old way of using confidential identities.
Yes.
It's just not going to convert the old identities to this new model.
Exactly. What you could try on your own is generating some transactions using confidential identities but not having enabled the new feature, and then doing some after having enabled it. And you will see that this table contains slightly different rows, some rows that have populated the left side and some rows that have populated the right side.
Okay, that makes sense. Is there any way to perform any migration from the old version to the new one?
At this moment, we don't provide any automated scripts, but probably we will provide something similar in the future for customers that might need to do that.
Yeah, to clean up after the new way has been implemented.
Yes.
Fantastic. Thank you very much, Dimos, for showing us all of this. Was there anything else you wanted to go through, or?
No, I think we've covered a pretty big part of the new feature. If the viewers have any problem reproducing the example or have any questions around the feature, we are always available in our public Slack or in our email lists.
Or on Stack Overflow, where your answers can be used to help other users too. Thank you very much again, Dimos.
You're welcome.
And thanks everyone for listening. Stay tuned for more videos in the near future.